Section 6.1 is on operations on functions. So functions can be added, subtracted, multiplied, or divided. Here's what the notation looks like. So f plus g of x is the same as f of x plus g of x. You just add the two functions. F minus g of x is equal to f of x minus g of x. Just subtract the two functions. And f times g of x equals f of x times g of x. Multiply the two functions. And f divided by g of x is f of x divided by g of x. And recall that the denominator cannot be 0, so g of x cannot equal 0. So let's take a look at a couple examples here. Given that f of x is 3x squared minus 2x plus 1, and g of x is x minus 4, find each function and then indicate any restrictions on the domain or the range. So the first one is f plus g of x. So that's going to be basically just f of x, which is 3x squared minus 2x plus 1, plus g of x, which is x minus 4. So to evaluate this, just combine like terms. So that's going to give me 3x squared minus x minus 3. And that's f of x plus g of x. Now to subtract, it's a little bit trickier, so I'll take f of x, which is 3x squared minus 2x plus 1. And now when I subtract, I have to put parentheses around g of x, x minus 4, because I need to subtract each term in there. So that's going to be 3x squared minus 2x plus 1 minus x plus 4, because minus a negative 4 is plus 4. Combining like terms, 3x squared minus 3x plus 5. Now f times g of x, I need to multiply those two functions. So 3x squared minus 2x plus 1 times x minus 4. And in this case, I'm going to have to use the distributive property. So I'm going to go a little backwards here. I'm going to distribute x to each term of my trinomial. So 3x cubed minus 2x squared plus 8x. Then distributing negative 4. It's going to give me negative 12x squared plus 8x minus 4. And now combining like terms gives me 3x cubed minus 14x squared plus 16x minus 16x minus 4. And that's f of x times g of x. And my last one, f divided by g of x, is going to be 3x squared minus 2x plus 1 divided by x minus 4. And we let the answer remain like this, but there is a restriction on the domain because x cannot equal 4. That would make the denominator equal to 0. So actually we don't do any polynomial division there, we just leave it like that. Now another way that we can combine functions is called the composition of functions. That means that the results of one function are used to evaluate another function. Another way to think of this is one function is kind of put inside of the other. And here's the notation. We have square brackets, and this is f of g of x. That's not actually a 0 or an O, it's just kind of like a little tiny little circle. We say f of g of x can also be written like this, f of g of x. As you can see, g of x is put into f of x. And what that really means is that the range of g, so whatever the outputs are, whatever the y's are inserted as the domain or the x's in the function f. Here's the other way we can write it. We can do g of f of x, which can also be written like this. And in this case, the range or the outputs of f are used as the inputs or the domain of g. And we call the result a composed function. Let's take a look at a couple examples that use this. This first one's a little more complicated, but if you kind of get the rhythm of the way it works, we can figure it out. So for each pair of functions, find f of g of x and g of f of x if they exist. State the domain and range for each composed function. So for the first one here, first example, we have two sets of ordered pairs. Function f is this set of ordered pairs, and function g is this set of ordered pairs. So first we're going to find g of f of x. We're going to evaluate g of x and then use that to find f of x. So this is the way I'm going to write it. I'm going to do f of g. Now I'm going to go to my g function over here and I'm going to insert each x. So f of g of 7, okay, because remember this means f of g, so g is inside f, and I'm going to take my first x in my g, and that's actually the same as f of 0, because when I evaluate g of 7, 7 being the domain, I get 0 as my range. Now I go back over here to my f function. Where do I see 0 as an x? Right here in this ordered pair, so f of 0 is -1. That gives me the ordered pair 7, -1. And that's the first ordered pair in the composed function f of g of x. Let's do that with the next one. So f of g, now I'm going to take the x coordinate of my second ordered pair in g, -1, is the same as f of, so g of 1 is actually 7, so I need f of 7. Let's go over here to f. Where do I see 7 as an x? Right here, and f of 7 in this case is 7, so that gives me the ordered pair -1, 7. Now I'll do it with my third ordered pair in g, which is 4, so I need g of 4, or f of g of 4. G of 4 is 9, so I need f of 9. Going over here to f, I see a 9 here. F of 9 is 4, so that gives me the ordered pair 4, 4. And I have one ordered pair left in g, and that's 8, 2. F of g of 8 is the same as f of 2. And when I go over to this function, f of 2 is 6. So that gives me the ordered pair 8, 6. So f of g of x is equal to this set of ordered pairs. 7, -1, -1, 7, 4, 4, and 8, 6. Okay. The domain is the set of all the x's of this composed function. So that would be 7, -1, 4, and 8. And the range is -1, 7, 4, and 6. Those are the y's of this composed function. So that's f of g of x. Now we need to find g of f of x, and we pretty much do kind of the same thing. But in this case, I'm going to do g of f. So I'm going to start with f, and I'm going to take each element of the domain of g of f and put in here. So g of f of 2, because that's my first x in f, is the same thing as g of f of 2 is 6. So I need g of 6, so I need to go over to g, and where do I see an x of a 6? I don't have one, so that's actually undefined. So I cannot find g of f of 2. It does not exist, so we say that it's undefined. So now I need g of f of 9, and f of 9 is 4, so I need g of 4. Let's go over to g. Here's g of 4 is equal to 9. So that gives me the ordered pair 9, 9. G of f of 7 is the same as g of f of 7 is 7. So g of 7 is equal to 0. That gives me the ordered pair 7, 0. And with my last ordered pair in G, I need in F, G of f of 0. F of 0 is -1, and G of -1 is 7. So that gives me the ordered pair 0, 7. So g of f of x is the set of ordered pairs 9, 9, 7, 0, and 0, 7. The domain is 9, 7, 0. The order doesn't really matter. I think in the textbook they put them in numerical order. And the range is my y's, 9, 0, and 7. So that's how you do a composition of functions if you're given the functions as sets of ordered pairs. The next way you can do it is if you're actually given algebraic expressions for the two functions. And to be honest, I think this one's a little bit easier. So we need to find f of g of x and g of f of x. So f of g of x. And for this one, I kind of like to write it like this. F of g of x. Because this one's a little more obvious as to you're putting one function into another. So what I need to do is take g of x, in other words, this expression here, 2x minus 1, and put that into f everywhere I see an x. So that's going to be 3 times, not x, but g of x, 2x minus 1 squared, minus x, and I'm going to put g of x in for x, plus 4. So the idea is I'm basically taking g of x, this whole expression right here, and plugging it into f everywhere I see an x. Now I just need to simplify this. So this is going to be 3 times 2x minus 1 squared gives me 4x squared minus 4x plus 1. Make sure you FOIL that. And then minus 2x, distributing that minus, that's going to give me a plus 1 plus 4. Let's distribute the 3. 3, oops. It's going to be 12x squared minus 12x plus 3 minus 2x plus 5 for a final answer of 12x squared minus 14x plus 8. Now, any restriction on the domain and range? No, the domain, or actually this one said state the domain and range. The domain of this one is going to be all real numbers. Oops. And how do I know that? Well, my composed function, f of g of x, is actually a quadratic. 12x squared minus 14x plus 8 is actually a quadratic, and if I were to graph that, I could see that that is, but you should know that because it's an x squared, and the domain of all quadratic functions is all real numbers. Now the range here is going to be a little trickier, because the range, because this is a quadratic, it's going to be graphed as a parabola. So use your calculator and find, in this case, what would be the minimum value of that parabola. Since a is positive, it's going to be opening upwards. So using my graphing calculator, I found that the minimum value is 3.92, so y is greater than or equal to 3.92, and that would be the range. Now, to find g of f of x, for this one's actually going to be a little bit easier. In this case, we're going to put f into g. So that means that I'm going to take this, my f function, and plug it into g for x. So I'll have 2 times f of x, which is 3x squared minus x plus 4, minus 1. So that's 2 times f of x minus 1, or 6x squared minus 2x plus 8 minus 1, or 6x squared minus 2x plus 7. And give myself a little more space here. There we go. My domain, again, since this is a quadratic function, is all real numbers. The graph of this is a parabola opening upwards. So my range is the set of all y such that y is greater than or equal to. And using my calculator, I found out that the minimum value of this function was 6.83. So again, in this section, we took a look at operations on functions that you can add, subtract, multiply, and divide functions. And you can also do this funky thing called composition of functions, where you basically put one function inside of another.